Previous algorithms learned independently. Gradient boosting takes a completely different approach. Instead of building many independent models, it trains each new model specifically to correct the mistakes made by the previous ones. Gradient boosting starts with simple models called weak learners. Individually, each one performs only slightly better than random guessing. But together, they become remarkably powerful. And notice, they stand in a sequence, not a forest. The first model makes predictions, but naturally, some are incorrect. Instead of ignoring these mistakes, gradient boosting treats them as valuable information. Rather than solving the original problem again, the next model focuses only on the remaining errors, known as residuals. Every new tree specializes in correcting what previous trees failed to learn. Watch the total error fall. Unlike random forest, where trees work independently, gradient boosting trains its trees sequentially. Every new model improves upon the previous one. The word gradient comes from optimization. Imagine a ball rolling downhill toward the lowest point. Similarly, gradient boosting continuously moves toward smaller prediction errors by following the direction of greatest improvement. Several modern implementations have made gradient boosting even more powerful. XGBoost became famous for winning machine learning competitions. LightGBM is optimized for speed and massive datasets. CatBoost excels when working with categorical features. Let's recap. Boosting chains simple weak learners one after another. Each new tree predicts the previous ensemble's residual errors, so the total error keeps sliding downhill, which is exactly where the word gradient comes from. Gradient boosting has become one of the most successful machine learning algorithms ever developed. It powers financial systems, healthcare applications, recommendation engines, manufacturing, search ranking, and many of today's highest performing predictive models. Gradient boosting combines many simple models into one powerful predictor, but another revolutionary approach draws inspiration from biology itself. In the next episode, we'll explore artificial neural networks and discover how machines learn through interconnected layers of artificial neurons.